Hey everybody, this is our video on earth cycles. So we're going to first start with the carbon cycle because this is probably the most important one for you to know. Oh, let me get this to go away. Scoot my picture over. Okay. So we know that carbon dioxide is in the atmosphere. It is released into the atmosphere by a couple different ways. So first off, burning fossil fuels. We know that with basically any sort of vehicle that's not an electric vehicle, you're giving off carbon dioxide or giving off carbon, leading to the carbon dioxide in the atmosphere. Remember, it's also released by animals during cellular respiration. We release carbon dioxide, gets in the atmosphere. It's pulled from the atmosphere by plants to be used during photosynthesis so that it can make the sugars. And then as those plants die, so we're going to go through the ground first. So as those plants die, they will produce carbon dioxide in the fossil fuels, or it'll, be decaying from waste, anything like that. Becomes carbon dioxide in the fossil fuels. The fossil fuels are then used for the car, and we start that process over. Or the plants can be eaten by the animals, released in waste, and then go down into this carbon dioxide section. So it is a cycle. That's why we call it the carbon cycle, because you keep moving in the circular motion as it's produced, used, produced, used. So the carbon cycle begins with the autotrophs, so the plants. Plants go through photosynthesis, which we know, and they use the carbon dioxide and sunlight to form oxygen in their food, which is sugars. So after the plants have used the carbon dioxide from the air in photosynthesis, then they use the food as energy in the process of cellular respiration, and carbon is released back into the environment through that sort of respiration in plants. Animals can also either eat those plants, and some of the carbon is transferred from the plant to the animal. They also eat other animals, which have carbon. And the consumer, the animals, will go through cellular respiration and put carbon back into the environment. So here's just another quick look at that. If you want to pause and get this really written down in your notes, you can. When dead animals and plants are left on the surface of the earth, they will decompose. We've got scavengers that will help do that. They'll just decompose by nature and get broken down and kind of pushed back into the soil. And that carbon is deposited through this decomposition and then kind of transferred into those fossil fuels. So if they decayed millions of years ago, the deposits of carbon from the decaying plants and animals were compressed, chemically altered, and experienced extreme temperatures, and that altered those carbon molecules, and these became what we call fossil fuels today, which is coal and oil. And then, as we know, the fossil fuels are used as energy sources for us, whether that be energy for cars, whether that be energy for like the lights in our house, anything like that. And since these fossil fuels are carbon compounds, the carbon that is being burned is getting released back into the environment. The one downside to this, well, not one, there's multiple, but one major downside to this is that these are non-renewable. So that means once they're used, you can't keep using it. You got to make more. And even though the earth is still producing reserves of fossil fuels, they're being used up faster than they are being made, which is leading to our energy crisis that is discussed constantly when it comes to politics. So how do carbon emissions relate to global warming? So global fossil carbon emissions. So you can see these here. Petroleum, that's gas. So that's the blue one. You can see how high that is, especially from all of these really from 1950 to 2000. You see that huge spike that they've got. Coal burning, natural gas that we've got, and then cement production. You can tell that coal burning has been high for a while, but that's because for a long time that was the only way used to heat houses and things like that. But altogether, the total black line that you can see is up between 6,000 and 7,000 metric tons of carbon per year, million metric tons of carbon per year. So now let's go into the water cycle. So water cycle, let's just start at the sea down here. So with evaporation from seas and lakes, we get water back into the air. It can be transferred from wind and go up to colder areas where it will become will condense down into liquid form or solid form, come down as snow. It could come down as precipitation depending on the temperature. We also have rain that will build up and release it back to the earth. As the snow melts or the water runs down, it becomes infiltration and then becomes basically runoff and groundwater. So transpiration, evaporation from plants. So water starts in the oceans, lakes, and other bodies of water, evaporates out of those, and becomes water vapor in the air. The water will condense into clouds, and when the condensation builds up, it either rains, sleets, snows, or hails, and these are our forms of precipitation. The precipitation will be stored in underground storage reservoirs and will run off into rivers and streams and eventually back into the ocean. So here's just a basic picture of the water cycle. So this is the one to really kind of commit to memory. Now let's talk about the phosphorus cycle. So the phosphorus cycle, let's start with, where we'll start in here. So we'll start with plants. So plants release phosphorus to animals that consume the plants. And then the decomposers will get phosphorus from the dead plants. Phosphates will be in the soil. They leach out into the water. We've got geological uplifting, which will cause weathering from phosphates on the rocks between rain and then, the rocks that tumble down, leading to runoff in the water. There's phosphates in those solutions, and then you get that sedimentation to form new rocks. So all organisms require phosphorus to live. If you've never known that, you have to add phosphorus to your plants when they grow, things like that. And plants take up phosphorus from the soil, and animals get phosphorus from eating the plants. When those animals die, they'll be decomposed by your fungi, your bacteria that you've got, and that will put the phosphorus back in the soil. Phosphorus in water becomes incorporated in new rock formations over time as an insoluble compound, so down here at the bottom. And this is millions of years that we're looking at. The rock will become exposed and the rock will erode, putting phosphorus back into the environment again. And then the last one that we're going to look at here, but I think next to carbon, this is the most important cycle, is the nitrogen cycle. So we've got crops, our autotrophs. They if we look at those, we're all leading into, atmospheric nitrogen. So the plants will take in nitrogen from the soil. They'll release it as they're harvested, or they'll release it as plant residues. Volatilization will get nitrogen back in the atmosphere as well. But we've got, from atmospheric nitrogen, we have fixation and deposition, and animal manures and biosolids will all end up getting nitrogen back into the soil. And then we've got biological fixation by legume plants, so think like peanuts, things like that. That'll get us nitrogen in the soil, and that organic nitrogen could become ammonium or nitrates, which will then get taken up by the plants. They can also get leached out. We've got denitrification. We've got runoff from erosion, and industrial fixation. So fertilizers will also pull atmospheric nitrogen out and put it back in the soil as well. So our atmosphere itself is 98% nitrogen. Plants and animals cannot directly use nitrogen found in the atmosphere, so it has to be processed through a bunch of different chemical reactions. So we have special bacteria that can directly use nitrogen in the atmosphere and fix it so that we can benefit from it as well. And these are called nitrogen fixing bacteria. So the higher the trophic level organism is, will use nitrogen to make their proteins. Animal waste will decay by the action of the bacteria, and that creates nitrates and ammonias in the soil, and that's useful for plants to grow again. Denitrification bacteria in the soil can break down ammonia into the gaseous forms of nitrogen, which is not available for use by plants and animals. And another part of this cycle, we've got animals that will eat those plants containing nitrogen, which is again returned to the soil by animal waste and decaying plants and animals.